problem, 3 lead sheets in a factory are heated in a different temperatures, right? So all of these 3 are made by lead. An initial area, let's say this is 4 meters square, this is 4 meters square, this is 4 meters square as well. An initial temperature, let's say the initial temperature is 25 degree Celsius, and the first one, let's say heated up to 175 degrees Celsius, which is very important as it's different temperature mentioned in a question. Anyways, this one will be 150. This will be, let's say, 170 degrees Celsius. Now, what we have to do, we have to consider, as this is the lead sheets, so the linear expansion alpha is equals to 29 into 10 to the power minus 6 per Kelvin. And we have to compare the difference in mathematically, which we have to compare. We have to compare the area expansion for each of the sheet. So this is the sheet number 1, sheet number 2, and sheet number 3. Indeed, the very first sheet, the area expansion del A1 is equals to the value of alpha, which is 29 into 10 to the power minus 6 into the area 4 and the temperature difference of before it was 25 degrees Celsius and increase up to 175 degrees Celsius, so it will be 150 degree. So del of A1 is equals to 0.0348 meters square. Now del A2 is equals to by the way, we have to add a 2 here as well, so it will be 2 times actually. Anyways, now it will be 2 times, of course, 29 into 10 to the power minus 6 into the area 4 and the temperature difference is 125 for the second one anyways. So the value will be 0.0290 meters square. Now it's time for this sheet del of A3. Same as here, the value will be 29 into 10 to the power minus 6 into the area 4 and the temperature 170 minus 25, it means 145 degrees Celsius. So the result would be 0.0336 meters square. So we have got all the 3 values. So del of A1 is 2, del of A2 is 2, del of A3 is equals to 0.0346 0.0290 0.00036. By the way, here will be a point. Anyways, now if we divide by 0.029, so we have here 1, of course, and here we have got 1.2, and here 1.16. So the ratio will be this 3. So what actually we can comment after solving this problem, right? So here, when we actually increase the temperature, what will happen? The area expansion is directly proportional to the change of temperature, right?